Welcome to Maths class of Standard 10. Today we are going to see the first unit. In it we are going to see functions. Already you must have learnt about relations. Function is nothing but a specific relation. Now come, let us see the definition of a function. A relation f between two non-empty sets x and y is called a function from x to y. For each x in x, there exists only one y in y such that x y belongs to f. So, in short we can say that f is equal to set of all ordered pairs such that for all x in x, y belongs to y. Now, let us see some new terminologies used in functions. Now, let us see some common terms used in function. First of all, you have to understand how to represent a function. We normally write it in this way: f is a function from x to y. I repeat it, listen carefully and see the way it is written. Always generally a function will be written in this way. And how do you read it? F is a function from x to y. And what are x and y? You have to remember that they are both non-empty sets. Now, what is the set x called in a function? We call it as a domain. We call it as a domain of the function. Set x is called as the domain of the function. And what is that set y called as? We call y as the codomain of the function. The set y is called as the codomain of f. Then range. Range is a subset of y. We will be seeing in examples where we have it as image. The elements which are images of f are called as range. So, obviously those elements will belong to set y. Therefore, it must be a subset of y. So, what is a range? Range is the images of f. Then coming to image. What is an image? Image is an element in y such that x y belong to f and that y is called as the image of x. I repeat it, image is an element found in the set y such that the ordered pair x y belongs to f and that y is called as the image of x, image of f. Next, coming to pre-image. Pre-image is an element in the set such that the ordered pair x y belongs to f. So, this x is called as the pre-image of y. X is called as the pre-image of y and y is called as the image of x. Hope you understood the meaning of image and pre-image. We will be using all these terms very often when we are doing sums and functions. So, what are the concepts you have learnt in functions? Suppose f is a function from x to y, then domain is the set x, codomain is the set y and range is a subset of y and image is an element in y such that x y belongs to f and y is called as the image of x, and pre-image is an element in x such that x y belongs to f. So, x is called as the pre-image of y. Now, let us see few examples of functions. Whenever there is a function, you must remember there must be two sets and you have to mention what that set is, whether it is a set of natural numbers or whether it is a set of real numbers or whether it is a set of whole numbers. Let me take for example here x and y. You can see that it is a finite set. X has got 4 elements, y has got 3 elements, x is equal to 1, 2, 3, 4 and y is equal to 5, 6, 7. Now, this is called as an arrow diagram. Usually, we draw this arrow diagram for representing a function. For example, the set x I have written inside an oval 1, 2, 3, 4 and for set y I have drawn another oval and written 5, 6, 7. Now, I have connected in this way. 1 is connected to 6, 2 is connected to 7, 3 is connected to 6 and 4 is connected to 7. Is it a function or not? You have to check. Yes, it is a function. How do you say it is a function? Each and every element of x is connected to the element of y in a unique way, only in one way. Therefore, this is a function of x. Now, let us go to the next example. F of x is equal to x squared. It is a very interesting function. It is a function from n to n. What does n represent? N represents set of natural numbers. So, you get the ordered pairs 1 comma 1, that is 1 squared is equal to 1. So, 1 is mapped, mapped means the image, 1 is mapped to 1 and 2 is mapped to 4, 3 is mapped to 9 and 4 is mapped to 16 and so on. So, this again you have to check whether it is a function or not. Yes, of course, it is a function. 1 is mapped to 1, 2 is mapped to 4, 3 is mapped to 4 and 4 is mapped to 16 and etc. 3 is mapped to 9 and 4 is mapped to 16 etc. So, definitely this is also a function. Then we will go to the third example. F of x is equal to minus 2x. When you see minus 2, what set of numbers comes to your mind? Minus 2 belongs to integer. So, it is a function from integers to integer. Z represents set of integers. So, we are going to see a function from set of integers to set of integers. F of x is equal to minus 2x. Let me take some set of ordered pairs. For minus 5, what is the mapping? Minus 5 into minus 2 is equal to 10. So, minus 5 comma 10. Next, you take minus 4. Minus 4 into minus 2 is equal to plus 8. Therefore, minus 4 comma 8. What is the next one? Minus 3. Minus 3 into minus 2 is equal to plus 6. Therefore, minus 3 comma 6. Like that it goes on. Minus 2 comma 4, minus 1 comma 2. What about 0? 0 into any number is 0. So, minus 2 into 0 is 0. So, 0 0 is another ordered pair. Then 1. 1 into minus 2 is minus 2. 1 comma minus 2. Then if you take 2, 2 into minus 2 is minus 4, 2 comma minus 4, like that it goes on. So, this again is a function because every element has got an image in set y. Definitely the answer comes only in the set of integers. Therefore, this is also a function. Now, let us see an interesting example. F of x is equal to 1 by x, where the domain is going to be n, natural numbers, and codomain is going to be set of real numbers. Now, let me start with 1. Natural number starts with 1. 1 if you take, what is the image? 1 by 1, that is 1. Then if you take 2, next number 2, the image will be 1 by 2. 2 comma 1 by 2 is the next ordered pair. What about the next number? 3 comma 1 by 3, 4 comma 1 by 4, like that it goes on. So, this is again a set of functions. So far we have seen various examples of functions. All these functions are called as real valued functions. In higher classes, you will be studying more about real valued function. What is a real valued function? It is set of real numbers. Domain and codomain will belong to set of real numbers. Such examples are called as real valued functions. So far, I gave you some examples of functions. Now, we will be seeing counter examples of functions. Counter examples means which are not functions. I will be giving you 2 examples now. Let set x is equal to a, b, c, d and y is equal to e, f, g, domain and codomain. Now, look at this function f. A, b, c, d is written here and e, f, g is written here. B is connected to f, c is connected to f and d is connected to g. Can you call this a function? No. Why you cannot call it as a function? Because the element A is not connected to the codomain. You have an element A in x which is not connected. What is the definition of function? Each and every element of x should be connected with the codomain, with the image. So, this is not a function. Now, next let us see another example. Let me take the same sets. X is equal to a, b, c, d, set y is equal to e, f, g. Now, you have x, a, b, c, d and set y, e, f, g. A is connected to E, A is connected to G, B is connected to E, C is connected to F and D is connected to G. Now, all the elements of x is connected. Can you call it as a function? Observe carefully and say whether can you call it as a function. No, only the first condition is satisfied, that is every element is connected to y, but it is not connected in a unique way. What is the definition of the function? Every element of x must be connected to y in a unique way. in a unique way is not satisfied. Therefore, this is not a function because A is connected to element E as well as A is connected to element G. Therefore, we call this is not a function of f. Now, I hope so you understand what are functions. Now, we will be going to the exercise 1.3. We will see some sums in exercise 1.3. Now, let us see the first sum. Now, let us see the first sum in exercise 1.3. They have given a relation like this: f is equal to set of all ordered pairs x y such that x y belongs to n. What does n represent? Set of natural numbers, and the relation is given as y is equal to 2x. The question is, you have to check whether it is a relation or not. So, let me draw the diagram. This is natural number n. So, 1, 2, 3, 4, 5 etc. it goes on, and this is also set of natural numbers. Okay, n is mapped to n 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 etc. Now, what is the relation? Y is equal to 2x. Let me take the first element 1, that means 2 into 1. 2 into 1 is how much? 2. So, 1 is mapped to 2. Yes, we get an element in the codomain. Next element 2. 2 into 2. 2 into 2 is 4. So, 2 is mapped to 4. Next, we will go to 3. 3 into 2 is 6. Next, 4 into 2, 8. Next, 5 into 2, 10. Now, what is the set of ordered pairs you are getting? 1, 2. Next one, 2, 4. Next one, 3, 6. Next, 4, 8. Next, 5, 10. It goes on like this. Now, are these ordered pairs in the set or not? Yes, they are. So, you can see that each and every element of domain is connected with the codomain in a unique way. Therefore, it is a function. Yes, it is a function. What about domain? Domain are set of natural numbers, and codomain? Codomain is again set of natural numbers. What about the range? What did I say about the range? It is the range is the set of elements which are connected with codomain. So, what are the elements which are connected with the domain? That is 2, 4, 6, 8, 10 etc. are the images. Set of images are called as range. So, range you will get it as 2, 4, 6, 8 etc. Range is equal to 2, 4, 6, 8 etc. 2, 4, 6, 8, what are they called as? They are nothing but set of even numbers. So, range is set of even numbers. Domain set of natural numbers, codomain set of natural numbers. Now, let us take another example. The function is defined like this: f is a function from x such that x squared minus 5x plus 6. We have to calculate certain values. See, whenever the sets are not mentioned, you have to assume the sets are to be real valued functions. Let us calculate f of minus 1. F of minus 1, how to calculate? In the place of x, you have to write minus 1. So, minus 1 squared minus 5 times x means minus 5 times minus 1 plus 6. Minus 1 squared is 1, minus 5 into minus 1 is plus 5 plus 6. So, it is equal to 12. Therefore, f of minus 1 is equal to 12. We got the answer. Or you can write it as minus 1 comma 12, that is one ordered pair. Now, we have to calculate f of 2. So, in the place of x, you have to replace 2. So, this will be 2 squared minus 5 times 2 plus 6. How much? 2 squared is 4, minus 5 times 2 is minus 10 plus 6, plus 4 plus 6 is plus 10, plus 10 and minus 10 is equal to 0. Therefore, f of 2 is equal to 0, otherwise 0, otherwise you can write it as 2 comma 0. is the second answer. Now, coming to the third answer, f of 2a, f of 2a. F of 2a, that is in the place of x you have to replace 2a. Here you have to note that a is again a variable, x is also a variable, a is also variable, but what is the functional value here? Function of 2a you have to find out. That means, wherever you have x, replace it with 2a. So, how do you write it? You write it as 2a the whole squared. Remember, it is 2a the whole squared. You should not say it as 2a squared, it is wrong to say so. You have to say it as 2a the whole squared. Only then the square is for both 2 and a. If you say just merely 2a squared, then the square is only for a squared, which is not so. It is 2a the whole squared minus 5 times 2a plus 6a. 2a the whole squared means what happens? It is 2 into 2 4 and then a into a squared. So, you understand the meaning of 2a the whole squared. So, it is 4a squared minus 5 times 2a is 5 into 2 10 minus 10a plus 6. This will be the answer. Because we do not know the value of a, we have to leave the answer as such. So, the answer will be, the image will be 4a squared minus 10a plus 6. That is 2a is mapped to 4a squared minus 10a plus 6. Now, coming to the last one, again you have a variable, you have to find the function of x minus 1, x minus 1. We do not know what is the value of x minus 1, but in the place of x, replace it as x minus 1. In the functional value is x squared minus 5x plus 6. Do you understand? So, in the place of x, you replace it as x minus 1. So, what happens here again? X minus 1, how do you say? X minus 1 the whole squared. X minus 1 the whole squared minus 5 times x minus 1 plus 6. So, x minus 1 the whole squared, you can use the identity a minus b the whole squared. So, you have to be thorough with the identities. A minus b the whole squared identity, using that you get x squared minus 2x plus 1. Then minus 5 times x minus 1 is minus 5 into x, that is minus 5x, minus 5 into minus 1, that is plus 5 plus 6. Now, we have to add up all the like terms. X squared you write as it is, minus 2x and minus 5x are like terms. So, it will become minus 7x plus 1 plus 5 plus 6 are like terms. So, it will become plus 12. So, the mapping will be x squared minus 7x plus 12. So, x minus 1 is mapped to x squared minus 7x plus 12. Did you understand, children? This is how we find the functional value. This is how we find the images for the given pre-image. Did you now understand how to find the functional values? This is how we find out the functional values for the given pre-images. Now, let us start the next example. F of x is equal to 2x plus 5. This is the function. And if x is not equal to 0, we have to calculate f of x plus 2 minus f of 2 divided by x. Why they have given x is not equal to 0 is because x comes in the denominator, and you know that we cannot have denominator as 0. When we have denominator as 0 in any sum, we call it as indeterminate. That is why they have given the condition x is not equal to 0. Now, let us start doing the sum. F of x plus 2, what should we do? In the place of x, we have to replace f of x plus 2. So, let us do step by step. Let me calculate first f of x plus 2, what is the functional value. So, f of x plus 2 is equal to 2 times x plus 2 plus 5, that is 2x, 2 into 2 4 plus 5, that will be equal to 2x plus 9. So, f of x plus 2 is equal to 2x plus 9. Now, what is f of 2? We have to calculate. The second step is we have to calculate the functional value for 2. That will be equal to 2 times 2 plus 5. That is 2 times 2 is 4 plus 5, that is equal to 9. So, now we have to find, in the third step, we have to find f of x plus 2 minus f of 2 divided by x. So, let me take it. This is step 1. Let me call it as step 1. This is step 2 and step 3 the final step, that is 2x plus 9 minus 9 divided by x. This is going to, let me call it as step 1, let me call this as step 2 and step 3. Step 3 is the final answer, 2x plus 9 minus 9, plus 9 and minus 9 gets cancelled. So, this will be equal to 2x divided by x, and x is not equal to 0. Therefore, we can cancel this x, numerator x and denominator x gets cancelled and you get the value to be 2, the answer. Therefore, f of x plus 2 minus f of 2 divided by x is equal to 2. So, the answer is equal to 2. Now, in this sum, the functional value is given like this, f of x is equal to 3 minus 2x. The question is, you have to find the value of x such that f of x squared is equal to f of x the whole squared. I repeat, you have to find the value of x such that f of x squared is equal to f of x the whole squared. First of all, you have to understand that f of x squared is different from f of x the whole squared. Now, let us see the sum, then you will understand. What is f of x squared? F of x squared means wherever you have x, you have to replace x squared in the functional value. So, f of x squared will be like this, is equal to 3 minus 2 times x squared, that is equal to 3 minus 2x squared, 3 minus 2x squared. This is left hand side, we can call this as LHS, f of x squared. Now, we have to find RHS. What is in the RHS? F of x the whole squared. When you are reading it itself, you read it like this, only then you will get the meaning, f of x the whole squared. What is f of x? 3 minus 2x. That means, it is 3 minus 2x the whole squared. F of x the whole squared means 3 minus 2x the whole squared. 3 minus 2x the whole squared, we can use algebraic identity, a minus b the whole squared, that you have to be thorough with the identities. A minus b the whole squared is equal to a squared minus 2ab plus b squared. So, this will be 3 squared minus 2 times 3 times b, 2x plus b squared, plus b squared is 2x the whole squared. Again here it is 2x the whole squared, it is not 2x squared, you have to read it as 2x the whole squared. So, what happens here? The value 3 squared is 9, 2 into 3 into 2 is 2 3s are 6, 6 2s are 12, minus 12x plus 2x the whole squared means 2 into 2 x into x, that is 4x squared. Now, like terms you have here, if you have like terms, it is not 9 squared, it is 9, 3 squared is 9. If you have like terms, you can simplify, but you do not have any like terms here, all are independent terms, different terms, unlike terms, 9 minus 12x plus 4x squared. This is right hand side value you are getting. Now, the question asked is, the left hand side value and right hand side values must be equal. So, you take the left hand side value, 3 minus 2x squared is equal to 9 minus 12x plus 4x squared. Now, we can simplify, minus 2x squared you take it that side, that is called transposing the term, minus 2x squared you can take it from LHS, you take it to RHS. So, it will become 3 is equal to 9 minus 12x plus 4x squared plus 2x squared. So, 4x squared and 2x squared are like terms. When you add these two, it will become 6x squared. Similarly, plus 3 when you take it that side, plus 3 when it is transposed, it will become minus 3. So, the answer will be like this, 4 plus 2, 6, 0 is equal to, I am taking 3 also that side. So, minus 3 plus 9 minus 12x, 4x plus 2x squared plus 6x squared. So, the answer minus 3 plus 9 are like terms, minus 3 plus 9 are like terms, you can simplify these terms, minus 3 plus 9, one negative, one positive, it will become plus 6. So, the answer will be like this, 0 is equal to 6 x squared minus 12 x plus 6. Now, what is the common factor here? 6 x squared minus 12 x plus 6. All the 3 terms are divisible by 6. Therefore, what can you say? 6 is called as the common factor for all the 3 terms. Therefore, divide by 6. You get it as x squared minus 2x plus 1 is equal to 0. X squared minus 2x plus 1 is equal to 0. Remember some identity. This is a very familiar sum with algebraic identity. X squared minus 2x plus 1. Are you able to get that identity? Yes, it is x minus 1 the whole squared. It is x minus 1 the whole squared is equal to 0. X minus 1 the whole squared is equal to 0 means the x value is equal to 1. X is equal to 1. But you must remember this identity, it is of a squared minus 2ab plus b squared, where a is taking the value x and b is taking the value 1. Therefore, we have written using the algebraic identity x minus 1 the whole squared is equal to 0. If x minus 1 the whole squared is equal to 0 means x minus 1 is equal to 0. If x minus 1 is equal to 0 means minus 1 will be transposed to the other side. Therefore, the value of x is equal to 1. So, when you get x value to be 1, you will get f of 1 squared and f of 1 the whole squared, both the values to be same. You can even calculate and verify the values will be same. Okay children, we have seen about functions and important concepts used in functions and some examples of function and also the exercise sums. In the next class, we will be seeing about types of functions and how to represent functions in different ways. Thank you children.